Okay, good afternoon.
Good afternoon po, ma'am.
Okay, so this is the second part of the variable stress analysis. Okay, so this time it is with stress concentration. Okay, so how do you know that the analysis is with stress concentration? It is when, okay, the member comes with a stress razor. Okay, so when we say a stress razor, these are surface discontinuity. Okay, wherein the stresses are concentrated on that area, making that area weak. Okay, so samples of stress razor, that includes the following. Okay, so you have there the hole, the fillet, and the groove. Other types of stress razors, say for example, the cracks, okay, cracks or say blowholes, even corrosion, okay, they are also stress razors. But then they are different from this tree in such a way that these are part of the design. Say for example, you have here your machine member. Okay, say for example, this is the machine member wherein you have there a groove and then a sudden reduce of the cross section, that is your fillet, and then say you have here the hole. Okay, so this one is the hole, this one you call this the groove, okay, and then this one you call it fillet. Okay, so these are, okay, the uh, surface discontinuity in a machine member. And if you take a look at these three, okay, these are simply uh, part of the design of the machine member. Okay, wherein they serve a certain purpose. Say for example, our monoblock chairs. Okay, so you would see that doon po sa back, okay, nung ating monoblock chairs, they come with yung ano po, yung holes, okay, which serves as a passage for air. Okay, so for air circulation, they do include the holes on the back and back part ng pong atin na chair. Same thing with the seat itself. Okay, so because it serves a purpose, so it's part of the design. But then when you say a stress razor such as the crack or the blowholes, they are really not part of the design. Say the blowholes, that is the air that is trapped along the thickness of a glass. Okay, so you would observe this on our glass bottles. Okay, so these are not really part of the design, but then through the process, okay, you have come up with those surface discontinuity. Okay, so hindi po yun yung minimin natin dito na stress concentration. Okay, so we are only after these three which are really part of your design. Okay, so kailangan po may ganun. Okay, so these are part of the design and that should be accounted in your computation for the appropriate dimension. Okay, so we have to account for this since they become the weakest part of the member, okay, having this stress razor. Okay, so how do we design, okay, a member under variable stress and also at the same time with stress razor? Okay, so the same thing po, we will be using the Soderberg and the Goodman equation. Okay, so still the Soderberg, since it's a variable stress. Okay, so for the Soderberg equation, you have 1 over Fs equal to sigma m over sigma y plus sigma a over sigma n. Okay, and then for the Goodman, we have 1 over factor of safety equal to sigma m over sigma u plus sigma a over sigma n. Okay, so it only differs on the use of sigma y and sigma u. And then you have also the other form, 1 over Fs in tau, so tau m over tau y plus tau a over tau n. Okay, so 1 over Fs equal to tau m over tau u plus tau a over tau n. Okay, so these are the equations. Again, the form, okay, yung tau po would be used for torsion and shear, okay, and then yung sigma will be used for axial, bending, and thin mold, okay. So this other verge, this would be used for ductile material, and then this one for brittle, okay. So the same set of equations will be used on this since both are variable stress analysis, okay. So ito din po yung ginamit natin last time, okay. So what is basically difference if you include here a stress ratio or stress concentration? So on the second term on the right side of the equation, you will be adding here a factor. So we call it Kf, and on the tau, it would be KFS. So i-multiply to sigma A over sigma N or tau A over tau N. Okay? So this is what is new. Okay? So you include there a factor. So we call this factor, okay? We call this factor Kf. So you call this the fatigue strength reduction factor. Okay? So we call this Kf fatigue strength reduction factor. And when you have their KFS, that is fatigue strength reduction factor in shear. Okay? So you simply add in shear. And the value of this Kf and KFS, they are just the same. Okay? KFS, Kf, this is equal to Q times quantity KT minus 1 plus 1. Okay, so this is our equation. Kf is equal to Q times KT minus 1 plus 1. Okay, so this is the factor that will take care of the stress ratios. Okay, so what is Q? Where your value of Q, we call this the notch sensitivity factor. Okay, so Q is the notch sensitivity factor. And how do you obtain the value of Q? Okay, where can you obtain the value of Q? Okay, you get your design tables, okay, and you go to figure AF7. Okay, everyone. So you go to figure AF7, you get your design tables, and then go to figure AF7. I think that is on page 22. Okay, so this is your figure AF7. Okay, so hand in with you yung copy po. Okay, so how do you use yung figure AF7 to obtain the value of Q? Okay, so yung Q natin, wala. Wait lang po ha. Ulitin ko lang po ate. Okay, so this is figure AF7. Yan. Okay, so how do you use figure AF7? This will be used. Okay, so this will be used to obtain the value of Q. Okay. Yan. So yung Q can be obtained in two ways. So the first one is to use, okay, table 87. Sorry, this is figure 87, okay? Figure 87. So how do you use figure 87? Okay, on the x-axis, you would see here the notch radius, okay? So for example, we have a machine member and then you have a central hole. So just have the value of the radius of the central hole. Okay, if the member comes with a groove, so what would be the value of the radius of the groove? Okay, if it has fillet, then what is the radius of the fillet? Okay, so yun lang po yung titingnan natin. So what is the common mistake? So you are given here diameter, okay, diameter of the hole, 1/8 of an inch. Okay, so they tend to see here yung 1/8. Okay, again, this is the radius. Okay, so you need to divide this by 2. So what you would need would be 1/16. 1/8 divided by 2, that would be 1/16. Okay, what we have here on the x-axis is the notch radius. Okay, so just take a look at the radius. So meaning, to use this figure, okay, per ano po yan, okay, per stress razor, okay? So hindi po pwedeng magkasama. It should be say whole only, or groove only, or fillet only, okay? So say notch radius is 1/16, okay? And then see that we have here several curves. In fact, we have here 3, and each one is labeled according to the type of material. Okay, so the first one, this is for quench and tempered steel. Okay, the second one is for annealed or normalized, and then the last one, which comes in a broken curve, you have there an aluminum alloy. So this is exclusive for aluminum alloy only. Okay, but then for steels, you have the first and the second one. Okay, now if you are given say water quench and tempered, then you will be using this curve. Okay, if you are given normalized steel, you will be using this. What if hindi po ma'am quench and tempered, hindi po annealed or normalized, okay, you may look for its BHN. Okay, so you look for the BHN. If BHN is less than or equal to 200, okay, you use the curve for annealed or normalized. Okay, but then if BHN, okay, is greater than 200, you can assume to use quench and tempered steel. Okay? Hindi po pwede itong nasa baba kasi this is for aluminum alloy. Okay? So, if BHN value is greater than 200, okay, this is 200, then you make use of this one. Okay? So, yan po ang gagamitin natin. So, how do you use it? Let's say, for example, you have here diameter of the central hole is 1/8 inch, and then quench and tempered steel. So what you will look would be the radius 1/16. So you have this line for 1/16 extended up to the quench and tempered steel curve. Okay, and then you would see there now, okay, the intersection of the two. Okay, so this intersection, you find its value, okay, here po sa atin na y-axis. Okay, so for example, ito po yung value niya. Okay, so what would be now the reading? Okay, so you will simply estimate what is the value. So from this, what is your estimation? Anyone?
0.97 po.
Okay, so 0.97. Okay, so you estimate 0.97. So that is your estimation coming from your figure. Okay, this is figure AF7. Okay, figure AF7. Now, another way to obtain the value of Q is through an equation. Okay, so you make use of an equation. And where is that equation? That is also in your figure AF7. So you look at this equation. And so this is an equation for Q. Q equal to 1/1 plus A over R. Okay, so you use equation Q equal to 1/1 plus A over R. And I suggest that you make use of this instead of the first method. Okay, kasi this is merely an estimation. Whereas the second one, this will give you a precise value. Okay, so you make use of this equation. Q equal to 1/1 plus A over R. Again, it is not then stated also here on our figure AF7. Okay, so you may refer to this for the equation. Now, the equation, okay, involves R. Again, that would be the notch radius. So in our example, that would be 1/16. Okay, and what is this value of A? This is simply a constant. Okay, this is a constant for a given type of material. Okay, so the values of A, they are seen also in this figure AF7. So for example, this one, quench and tempered, A would be 0.0025. Okay, so this is the value. If it is annealed or normalized, A is 0.01. And if it's an aluminum alloy, A equal to 0.025. If BHN value is less than or equal to 100, A is equal to 0.01. And if BHN is greater than 200, you make use of this, 0.0025. So these values of A, okay, these values of A, these are also seen on your figure AF7. So you simply refer there A equal to this value taken from figure AF7. Okay? So you try to answer now what is the value of Q. Okay? Considering this equation, what would be our value ng Q? Okay? Try to to calculate the value. What is the answer? And then let us try to compare it with our estimation, okay, using figure AF7. What is the value?
0.9615 po.
Okay, 0.9615. Thank you. So 0.9615. You look at the value, okay, and the estimation that we have, this is 0.97, this is 0.9615, okay? So, although magkaiba yung value, but still, malapit pa rin naman, okay? So, kaya nga sabi natin, okay, you may use the two methods, but we suggest that we make use of the precise value, and that is using this equation, okay? Q equal to 1 over 1 plus A over R, okay? Wherein the A value that can be obtained again from this figure AF7, okay? So, yun po yung value natin for Q. So, let me go back doon sa lecture. So, we have here, again, yung Q will come from figure AF7, okay? And this is using the equation 1 over 1 plus A over R, okay? The A value that comes from this figure also, okay? So, using this equation, you'll arrive at an exact value, okay, of the Q. No need for estimation, okay? And then another thing is the value of KT, okay? So, what about this KT? So, when you say KT, this is called the theoretical stress concentration factor. Okay, so this is KT is theoretical stress concentration factor to be obtained from figure AF8 up to figure AF14. Okay, so look at figure AF8 up to AF14. Okay, so ito po yung AF8 and AF14. Okay, so figure AF8, okay, so this is specific for a flat plate with a central hole, okay? So see the illustration here, okay? So this is the machine member, and then you have there a central hole. So the dimension of the machine member, you have there H for the height of the flat plate, and you have here the thickness, okay? So this is the thickness, and so height and the thickness. So this is its cross section. So I have here the cross section, and so what would be the dimension of your cross section of your flat plate? That would be H by T. Okay, this is the height and this is the thickness of the plate. And then for the diameter of the central hole, you use small letter D. Okay, so what you need to do is to compare, okay, the given problem with the figures here, okay, and then see which figure will be applied, okay. Is it figure AF8 and up to figure AF14, okay. So AF9 would be for a flat plate also, okay. This time the stress razor is a fillet, okay. So you have here the fillet. Okay, so AF10, still a flat plate, but then this time you have there yung groove. Okay, and then AF11, still a flat plate, but with eccentric hole. You look at the hole, okay, so no longer at the center. Okay, so it's any position other than the center. Okay, so that is the flat plate with eccentric hole. AF12, this time, you have a different cross-section. Okay, kanina po, it's a flat plate. This time, you have a circular cross-section. Okay, so we have your shaft with fillet. You have your shaft with a radial hole on figure AF13. And then AF14 is a shaft with groove. Okay, so for 12 to 14, you have circular cross-section, and then you vary also the stress razor. Okay, so we have here is the groove, here is the hole. Okay, ang tanong is, where is the hole here? Okay, so it is on the topmost. Okay, so the hole is located here. Okay, so this is where the hole is located. What you see only is the dashed line, okay, and this pertains to the diameter of the hole, okay. So that is the diameter of the hole. Okay, so yan po yung ating figures AF8 up to AF14. Again, you simply compare, okay, the given problem with this figure AF8 up to AF14 and then decide which among this would be applicable. Okay? Now, how do you obtain the value of the KT? We are after the theoretical stress concentration factor. Say for example, we go to the figure AF8. Okay? So how do we obtain KT here? Okay, so this is what you will do. Okay, so you look first at the x-axis. So the x-axis is d over h. D pertains to the diameter of the hole, and h would be the height of the plate. Okay, so you look for its ratio, and then kukunin po natin ang value of this x-axis. Then you draw a line, okay, and then see kung saan po siya mag-tangent to this curve. Okay, so the curves here pertains to ito pong dotted ones, okay, the dashed ones. You have here the ratio b over h. Okay, b would be the distance, yung center of our hole to the leftmost part, that would be distance b. Okay, and then divide that by yung h, which is the height of your flat plate. Okay, so you need to obtain first b over h to see which among these curves will be used. Okay, for the the dotted curves, you have here loaded by F1 on a pin in the hole margin B. Okay, so meaning the force is applied exactly that of the hole or the pin. Okay, so dito po naka-apply yung atin na loading. Whereas for the solid curve, you have here force action part, and the forces are applied here, okay, on both ends of your plate. Okay, so that is how you would know the which among these curves would be used. Okay, if you will be using the dotted curves, then you need to know first the ratio between B and H, okay, to decide on which curve would be used. Okay, but then for the solid one, you only have one. Okay, ito lang po nasa gitna. Now, if you will be using the solid curve, you would have your reading on the left. Okay, this is theoretical KT using a solid curve. Here naman po is KT if you use a dotted curve. So if you use a dotted curve, reading would be at the right. But then if you use the solid curve, so reading would be at the left. Okay? Say for example, say given a diameter, okay, of say d over h is 0.1, okay, and you use a solid curve. So the point tangent, okay, wherein they meet, okay, this is 0.1 as the ratio, and then you have here solid curve, okay? So the value of KT would be taken on the left side, okay? So the value would be 2.7, okay? So the KT now would be equal to 2.7, okay? So you need this ratio first. Now, you look at the ratio. Okay, you look at the ratio. So the x-axis that contains the ratio. And the ratio involves the dimension of your machine member. Say for example, this one, D over H. H would be the height of the member, which is of course the unknown. Okay? Height is unknown, or say the thickness would be unknown. So you cannot obtain a value of the ratio since H is unknown. So how would you choose, okay, your line here on the x-axis if this H value is unknown? Okay, so how can you obtain the value of KT? So wala po. Okay, so ano pong gagawin? You need again to assume. Okay, so you need to assume a value of H. Okay, so you need to assume a value of H, a value of the dimension, and then get the ratio, and then go to the specific curve, and then you can find value of KT. Okay, the theoretical stress concentration factor. Okay, but then since you started with an assumption, okay, so the assumption is used simply to obtain a value of KT. Okay, so if you have your answer already, if you are done with your computation, you look at your final answer. Okay, so you have to evaluate your final answer if that is the same with your assumed value of H. So for example, you obtain through computation, your final answer, height is equal to 1 inch. Okay, and you assume here, say, H is equal to 1 inch then. Okay, then that will be your final answer. Okay, because the assumed value is the same as that of the computed value. Okay, so for example, you assume here H is 1, okay, 1 inch, and then you obtain your answer is 0.95 inch, okay, no, of an inch ang ating answer. So they are the same then since they have the same commercially available size, okay? So hindi naman po natin nire-require that you have you have the same answer, say 1:1, okay? So what we need only is that, okay, their commercially available size would be the same. Okay? For you to see that yung answer is correct. Okay? If the assumed value of H versus that of your computed value, okay, magkaiba po yung value, they are different, then you need to recompute. Okay? So you need to recompute. You will need here a different assumption. Okay? So para po maging malapit yung answer po natin, okay, ang gawin nyo po for your next assumption, yung naging answer mo po would be your next assumption. Okay? So yun po yung gawin nyo for the value, okay, maging malapit po yung answers po natin. Again, we will be accepting only the value when, okay, the commercially available size for both the assumption and that of the computed value are the same. Okay? Naintindihan po ba? Hello? May question
Yes
po
po.
sila? Okay, so ganun
Ma'am, yun
yung
po ay
gagawin
kahit
natin.
ano po ang i-assume po namin H na hindi po katulad nung iba po na may i-assume po kami na specific value.
Mag-assume po kayo ng specific value. Okay? You would be assuming
pero
a
kahit ano po.
specific value. Kahit ano. Kahit ano.
Okay po, thank you po.
Okay, so I'll give you a tip later when we have our sample problem on how you assume for a value. Okay, so let me continue. So this is how you obtain the value of your KT. Okay? For other figures, say for AF9, okay, the value of KT is simply read on the left side, okay, yung y-axis. It is only figure AF8 who has left and right y-axis, okay? But then for the succeeding figures, AF9 up to AF14, you only read the value on the left side, okay, on the left side. Yung y-axis natin on the left side, okay? So that is how you obtain po the value of KT. So here, you would observe that all ratio on the x-axis that contains the dimension. Say for example, this one, this is the diameter, okay? So almost all of these figures that contains the dimension. Say for example, you have here now yung circular, okay, or the shaft. So that involves the diameter of the shaft, which is the unknown. So in that case, again, you need to assume for the value. And then check later on, okay? If you have already your answer, then you need to check if they are the same. The same in a sense that they have the same commercially available size, okay? So that would be the value for KT. Now, what if you have, say, a shaft. Say you have there a shaft with a central hole, okay? So this is the shaft and then a central hole here, okay? So say you are given this diameter of the hole and then you are to look for the diameter of the shaft. So what would be the diameter of the shaft given this diameter of the hole, okay? So you try to examine now figure AF8 up to AF14, which will be applicable to this setup. Okay? Alin po yung gagamitin natin? Figure AF8, 9, 10, 11, 12, 13, 14, and 15. Okay? So you have to compare, okay, the given with the figures AF8 up to AF14. So for this case, which would be applicable? So this one is a shaft with a central hole. Okay? So shaft with a central hole. So which would be applicable to use from AF8 up to AF14? If you are to look for this illustration on 8 to 14, wala pong eksaktong katulad po nito. Okay? Kaya you need to decide which one would be its equivalent. Okay? Which one? 8 to 14.
AF13 po ba?
So you have there AF13. Okay, so take a look at AF13, everyone. Okay, so AF13, this is a shaft. Okay, so the same as the given. But then this is shaft with a radial hole. And you locate the hole, it is on the top. Okay, so this is the hole at the top. So this is simply a projection line of the diameter of the radial hole. Okay, so the hole is at the top, and from our given, okay, the hole is facing us. Okay, so this is different from the given. Okay, hindi po pwedeng ang gawin natin ay iikot natin, ma'am, para itong hole na to ay mapapunta po dito. Okay, so hindi po pwede yun. Hindi po pwedeng ikutin natin para mapapunta dito yung hole. What is the setup on the figures would be this, ayun na lang po, okay? Hindi po natin pwedeng baguhin, okay? So, meaning, this figure AF13, this cannot be used in relation to the given problem, okay? So, which is more likely to be involved, okay? So, this one, figure AF12, we cannot use this since it is a different, okay, stress razor. Same thing with AF14, for this contains a groove. What we need is a central hole. So in that case, we need, okay, the one which would be nearest to it would be your figure AF8. So we can modify this figure AF8. Instead of flat plate, okay, we can have it simply as a shaft, meaning a circular cross section, okay, with a central hole. Okay, so we can make use of figure AF8 for this particular sample, okay, a shaft with a central hole. So what we need only is to modify, okay. Say for example, we have here D over H, okay. So for example, if we have now as shaft, okay, so we do not have anymore the value of H and the value of T, okay. What we have only is its diameter, big letter D, okay. So how do you modify this one, yung D over H? So what would be its equivalent? What would be its equivalent if it is now shaft? Hello? So you try to see the illustration, okay, on our figure here, okay, figure AF8. So D pertains to the diameter of the hole. So it is usually given. We have there D, diameter of the hole, divided by, you have there H. H pertains to the height, okay? H pertains to the height of the flat plate. If we make it now a shaft, what would be the height? What should be the height?
Yung diameter po ng shaft.
Okay, it would be the diameter of the shaft, okay? So this one, yung D over H, that would be converted to D over D. Okay? So, equivalent niya po would be D over D. D, big letter D, defines the diameter of the shaft. And the small letter D, that would be the diameter of the hole. Okay? So, ito po ngayon yung magiging bago if you transform this to a shaft with a central hole. Okay? What else? What about this B over H? Okay? Instead of B over H, you make it now B over D. Yung H natin would be equivalent to the diameter. Okay? So this B value here would of course be given. Okay? So B over D. Okay, so that would be our value of KT. Okay, you need to modify it first and then we go to the corresponding curve that is to be used to obtain the value of KT. Okay, any question?
Wala naman po, ma'am.
Okay, so that is how you obtain yung KT. Okay, and from there, okay, you substitute at the equation KT is equal to Q times KT minus 1 plus 1. Okay, you use this equation. Okay, once you obtain the value of Q and the value of KT. Okay, so again, the KFS value, that is just the same as this. This is KF. KF. Okay? So, parehas lang po yan doon sa KFS. Okay? Now, so we go back again to our Soderberg-Goodman equation. Okay? So, what is new to us is the inclusion of KF and KFS. Okay? So, ito lang po dalawa. What else is modified if the variable stress analysis has a stress concentration, okay? It is on the value of your sigma M and sigma A, okay? Or tau M and tau A. So, we recall their equations, okay? Sigma M is equal to maximum plus minimum divided by 2. And your sigma A would be maximum minus minimum divided by 2. Okay? Yan po yung sigma M at saka yung sigma A. Okay? So, alin lang po yung nabago sa atin? It is the equation of your sigma max and sigma minimum. Okay? So, where can you obtain the value of your sigma max and your sigma minimum? Okay? So, saan po ba natin makukuha yung values po nung dalawa na yon? Okay? So, you can see that also on our design tables. Okay? So, you look for the equation of sigma. Okay? So, ito po, nakita niyo po ba? You look at this part. Okay, this is your sigma. Sigma equal to force over quantity H minus D times T. Okay? So, yun po yung ipapalit natin ngayon doon sa equation po natin. Okay? So, you have there, the equation is sigma equal to force over H minus D times T. Okay? So, this force that varies. Okay? So, you can now obtain sigma maximum. That is when you use maximum force over H minus D times T. Okay? And your sigma minimum would be equal to F minimum over A minus H minus D, H minus D times T. Okay? So, susundin lang po natin yung equation po na nakalagay on the figures. Okay? You simply follow these equations and then apply the maximum and the minimum value. Okay? So, the maximum and the minimum value, that applies only to the force. Okay? So, it applies only to the force. Have there yung pressure and also yung ano po natin. Moment. Okay? So, force, pressure, and moment. Okay? Doon po natin ina-apply. Okay? Yun pong ating equation, nung maximum at nung minimum value. Okay? So, for other figures po, you can easily see that po. Okay? Say, for example, this one. If member is in tension, so you use this equation. Sigma equal to force over dt. So, if you want sigma maximum, then F max over dt. If you want sigma minimum, F minimum over dt. Okay, this one is for bending. Okay, so this one is tension also. This one is bending. Okay. So, equations, okay, of maximum and minimum stresses, okay, they are seen on our figures. Okay, again, AF8 up to AF14. Okay, so that is how you obtain sigma M and the value of your sigma I. Okay, so looking at this, okay, sigma M, sigma A, okay, you have their sigma U and the value of sigma N. Okay, so for the value of sigma N, okay, this one is dependent on life of the material. Okay, so we have what we call indefinite life. At meron din naman po na definite life. Okay, so again, the definite life, this is expressed in the number of cycles or the number of repetitions. Okay, so yun lang po yung palatandaan natin on a definite life basis. Okay? Any question? Hello?
Wala naman
Question
po.
po? Okay. So we proceed to the sample problem. Yan. So a connecting link shown is under a maximum load of 10 kips, repeated and reversed. Okay, the link has a radial hole drilled through it at the center of the section. This machine from 2330 WQT 1000 degrees Fahrenheit. Determine the diameter of the link for factor of safety equal to 1.5. Design based on letter A, you have their indefinite life, and letter B is a definite life basis. Okay, so let me draw first the connecting link. Okay, so this is the illustration. You have there the connecting link. So circular in cross section. Okay, with you are looking for this diameter. Okay, so you have there a central hole, radial hole drilled through it at the center. Okay, so say this is the hole. So this one, we say that this is analysis with stress concentration because we see there already the hole. Okay, so what you are looking for would be what would be the dimension, what should be the diameter that you will be using. Okay, given this diameter of hole equal to 1/8 of an inch. Okay, may question po?
Wala po.
Okay, so this is what we are looking for. What should be this diameter? Okay, so we start with the given values. You have their maximum load equal to 10 kips. Okay, what type of load? Repeated and reverse. Okay, so that would be F maximum 10 kilogram. Then you have also the diameter. Okay, diameter of the radial hole. Okay, ano po yung diameter niya? Okay, say diameter would be 1/8 inch. Say given diameter of 1/8. Erase ko lang pa. Wait lang. Ano? Okay. Say diameter equal to 1/8 of an inch, for example. Okay. So include that. Yan. And then we go to material specification. So AISI 2330 WQT at 1000 degrees Fahrenheit. Please find value of sigma U, sigma Y, and the BHN. Oh, ano pa ang value? You use table 89. Okay, this is 105 KSI. This is 85 KSI. And BHN is 20. Kindly check nga kung 207.
207 po.
Okay. So BHN is 207. This is taken from table 89. And what is the page number for table 89? That is page 17. Okay, page 17. Yan. Next to material specification would be the factor of safety. So Fs is equal to 1.5 and this is given already. Okay. Sunod, after the factor of safety, we go with the design stress. Okay, so sa design stress, since this is a variable stress, we have also ductile material from given 2330, and then the basis of design based on the ultimate strength. Okay. Based on the yield strength, since ductile, and what type of loading, this is tension. Okay, so therefore you use okay, you use now a Soderbergh equation. Okay, so you use the Soderbergh equation since it's a variable stress, ductile, which is basically based on yield, and you have their tension. Okay, so we use now 1 over Fs is equal to sigma m over sigma y plus sigma a over sigma n. See that the member has yung hole at the center, so therefore you add here Kf. Okay, so this will be our working equation. Okay, the Soderbergh with our Kf value. Okay, 1 over Fs equal to sigma m over sigma y plus Kf sigma a over sigma n. Then you try to look for value of each component. Okay, so you look first for yung Kf. Okay, so from this, okay, your Kf is equal to Q times Kt minus 1 plus 1. Okay, so this is our equation. So you find value of Q first. Okay, Q is the notch sensitivity factor. Okay, so Q is equal to 1 over 1 plus A over R. So we see this equation from figure AF7. Okay, so you go to figure AF7. Okay? Yan. So, punta po ulit tayo doon sa figure AF7. Yan. So, this is your figure AF7. So, what is the notch radius? Okay? So, what is the notch radius? So, given diameter of the hole is 1/8, so you'll obtain there 1 over 16. Okay, 1 over 16. And then you have their quench and tempered. What is the A value? 0.0025. Okay, so that would give us, okay, yung pong ating value ng Q. Okay, so from this, we say for Q and T stills, A is equal to 0.0025. This is from figure AF7, okay, page 22. Okay, yan po. And then, galing po doon, you solve for Q. Q is equal to 1 over 1 plus A is 0.0025. And ano yung R natin? 1 over 16. Kasi given diameter is 1/8. Okay? So 1 over 16. So what would be the value of Q? Kindly compute. Yung 1/8 po natin, this is equivalent to 0.125. Okay? Inch. O, ano po ang answer din eh?
Compute niya po. 0.9615384
Okay, 0.9615. Tapos, i-ano nyo na lang po, idiretso na lang nyo po yung value. Okay? We will be needing this po. So, no need for it to be rounded off. Okay? So, you use the real value. Okay? So, Q is equal to 0.9615. Oh, you have here now yung Q. Yun naman po value ng KT. Okay? For the value of KT, you will use now figure AF8. Okay? So, let us have here the value of KT. Okay? Using figure AF8, why do we use figure AF8? Ito po yung shaft with central hole. Okay? So, we have discussed it kanina po. Okay? Shaft with central hole. Okay, so looking at the given, okay, this is the same as that of figure AF8. So you need to relate your given figure, okay, of the problem you are solving with the figures here. Okay, so basically the same po with this one. Okay, only that you will have a circular cross section. Okay, so in order to obtain the value of KT, okay, in order to obtain the value of KT, necessary you have here po first the x-axis. On the x-axis, you would have D over D, the ratio of D to the diameter of the shaft. Okay? So, yun po yung kukunin natin. Okay? So, using figure AF8, what you would have there is D over D on the x-axis. But then this D po, okay, this is 1/8. And then this one is unknown. Okay? So, meaning you cannot obtain the ratio. So, what you need to do is to assume a value. Okay? So, any value can be your assumption. Okay? Say, assume diameter equal to 1.25 inches. Now, question is, bakit po ma'am you assume diameter is 1.25 inches? Why is not that you simply make use of 1 inch? Okay? Why 1.25? Reason is D over D, your 1/8 there would be equivalent to 0.125. Okay? This is 0.125 over my assumption, 1.25 inches, and this will give me exactly 0.1. Okay? So, why do I assume this 1.25? It is because for me to obtain, okay, an exact, okay, line for 0.1. Okay? You do not know really the answer. So, any number can be an assumption. So, para for ease na pagkuha natin ng value ng KT, so I make use of 1.25 to obtain exactly 0.1. So, I have this line. Okay? And then, tangent to the solid curve. Okay? So, I have exactly KT equal to 2.7. Okay? So, for example, you assume value equal to 1. You assume value equal to 1, so that would be D over D. That would be 0.125 over 1, your assumption. Okay? So, this would yield 0.125 as the ratio. So, where is 0.125? This is 0.15. Okay? So, in between 0.1 and 0.15, wala naman pong linear. Okay? So, you need to estimate the value. Okay? Which is harder. Where in fact, you do not know naman po if that would be correct. Okay? So, it is better to use, okay, these values, okay, these lines wherein you have an exact value of the ratio. Okay? Kaya po, I use 1.25 and not this one. Okay? So, let me go back. Okay? So, I use here 0.1 and from that 0.1 D over D, okay, we obtain a KT equal to 2.7. Okay? So, we have here now KT equal to 2.7. Again, this is taken from figure AF8, page 22, I think. Okay? Is it page 22 nga ba? Okay, so page 22. Okay, so you have here now the value of KT, and dito po, you have your value of Q. Okay? Thus, you solve now for KF. KF is equal to Q times KT minus 1 plus 1. This is 0.9615 as our answer po kanina. Again, you make use of the real value, okay, for Q. KT is 2.7 minus 1 plus 1. Okay? So, be very careful with the parentheses that you use. Okay? Kasi that could change the real value. Okay? So, what would be the value for KF? Kindly compute.
2.635 gold.
2.63. Ano po kasunod?
4615385.
Say 2.63461. Tama, Miss Alisa?
Yes po.
Okay, so may kadugtong pa yon. Okay, you may include all other numbers. Okay, so this would be the value of KF. So better that you put all components of your Soderberg equation again in a box. Okay, so that we can easily substitute this to the Soderberg equation later. Okay, So you have there already the value of Kf. So Kf, sigma y, Fs. So what we need now is sigma m, sigma a, and sigma n. Okay? So sigma m and sigma a, this refers to the type of variable stress. Okay? So we have repeated, reverse, and fluctuated. Okay? We take a look again at the problem. Okay? Stated here would be maximum load of 10 kips, repeated and reverse. Okay? So repeated and reverse load. Okay? So if you have there repeated and reverse, okay, so since you have a repeated and reverse load. So on our types of variable loading, we only have there 3. Repeated, reverse, and then the last one would be fluctuating. But then this time, it's a combination, repeated and reverse. Okay? So if it is a combination, then we say reverse will prevail. Okay, so reverse will prevail. So you use only the property of a reverse stress. Okay, so if it is a combined loading, repeated and reverse, you use a reverse properties. Okay, what are the properties of a reverse stress? Anyone? Ano po yung mga properties of a reverse stress? Okay, Miss Elisa?
Sigma m po ay 0 po and yung sigma a po ay equal sa sigma ng maximum.
Okay. So this is the property of a reverse stress. Sigma m is 0. Okay. And your sigma a would be equal to sigma maximum. Okay. So that would be our equation. Okay. Sigma a equal to sigma maximum. Now, what would be the equation of your sigma maximum? Okay. So the equation for the sigma will be taken again from the table. Okay, we use table 88. Okay, we use this table 88. So you look now for the equation of the stress. Okay, so originally what you see here is sigma equal to F over H minus D times T. Okay, this equation. But then this is valid if you have a flat plate. We have modified this. Okay, we are to modify this base po doon sa ginawa nating shaft with central hole. Okay? So, if it is shaft with a central hole, what would be now the value of your stress? Okay? So, the value of the stress this time would be equal to what? The force over what would be the corresponding to the area. This is H minus D times D. This one, if binilog na po natin yan, it would be pi D squared over 4 minus D times D. Okay? So, ito na po yung gagamitin natin if we have a shaft, okay, with a central hole. Okay? So, we will make use of this. And if we are looking for sigma maximum, then the maximum value will be applied doon sa force po natin. Okay? So, instead of this, if it is circular in cross-section, then you make use of this one. Okay? As modified po yung figure AF8. So, applying that, okay, so we'll have here F max over pi D squared over 4 minus D times D. Okay? And then you substitute those values. Okay? So, what are then those values? Okay? We have now F max is 10 kips divided by pi over 4 D squared minus D is 0.125 times yung D. Okay? So, your sigma A would be in terms of the diameter. So, this would be 10 kips, 10 divided by, what is pi over 4? Kindly compute. Minus 0.125D. Ano po itong unang term? Hello?
0.785.
0.785
3981634 po.
for d squared minus 0.125d. Okay? So, ayan po. Just have here the real value. That would be your sigma A. Okay? So, this would be your sigma A. 10 over 0.7854 d squared. Okay? Minus 0.125d. Okay? And then you go back again to your Soderberg. So, sigma n, yun na lang po yung locking. Okay? So, for letter A, sigma n is dependent on the life of the material. For letter A, you are asked to design for indefinite life basis. Okay? So, for letter A, we use indefinite life. Okay? For indefinite life, kindly look for the equation for your sigma n. Okay, so this is for axial or tension. Okay, so what is our equation? Sigma n is equal to 0.8 sigma prime n times the surface factor. Okay, so this is our equation. Okay, so try to see this on our last discussion. Okay, so for sigma prime n, that is the endurance limit. Sigma prime n is equal to 0.5 of sigma u. Why do we use this value, this equation? Because this is dependent on the BHN value. Okay, the BHN here is 207, which is less than 400. So if BHN is less than 400, you use 0.5 of sigma u. Okay, so from there, you use 0.5, sigma u is 105 KSI. So this will give us 52.5 KSI for your sigma prime. Come on. Yeah. Huli kang magpasahod, mami. Kaya, ano. So, that would be sigma prime n, 52.5 KSI. For the surface factor, you have to know the type of surface. Okay? So, you go back to on po. It is indicated here, it is machined from AISI 2330. So, the type of surface is machined. Okay? So, machined surface. So, where can we obtain the surface factor? What particular figure? What particular figure will be used for the surface factor? Yes, Von?
AF5 po, ma'am.
Okay, correct. We use figure AF5. Okay, so we go to figure AF5. Yan, okay? So this is figure AF5. So what you need here would be the ultimate strength. So ultimate strength, okay, of the given material is 105. Okay? So hindi pala dito. You have here 105. Okay? So sigma u equal to 105 KSI. Okay? So have here a line, okay, for 105, and then it should with this machine, okay, surface. Okay, and then find this point, okay, and have its reading on the left. Okay, so approximately 0.85, okay, or say 85%. Okay, so you use 0.85 for the surface factor. Okay, so surface factor is equal to 0.85 taken from figure AF5. This is on page 21. Okay, page 21. Yan. So, having this, you can now solve for sigma n. So, that would be 0.8. Sigma prime n is 52.5 KSI. And then the surface factor is 0.85. So, what would be the value? Paki-compute po ako. What would be the value?
35.7 po. KSI.
Again,
35.7 KSI.
35.7 KSI. Okay? So, all components now of the Soderberg equation are completed. Okay? So, you now substitute. Okay? So, substituting, to this other bridge. So 1 over factor of safety, that is 1.5, equal to, you have there sigma m is 0 and sigma y is 85, plus you need kf 2.63461, 2.63461 multiplied by, you have there sigma a. What is sigma a? You have this 10 divided by 0.7854 d squared minus 0.125 d. Okay? And then divided by sigma n. What is the value of sigma n? 35.7. Okay? And then you try to simplify. 0 over 85, this is 0. So we have 1 over 1.5 equal to 2.63461 divided by 35.7 multiplied by 10 divided by 0.7854 d squared minus 0.125 d. Okay, so what you will yield here, okay, you try to simplify all of this, you'll have here a quadratic equation. Okay, kasi you have here d squared and d. So what you would obtain would be a quadratic equation. Okay, and then after you have here the equation, you use now the quadratic formula. Okay, so using quadratic formula to obtain the value of d. Okay, which is the quadratic formula? Negative b plus minus square root of b squared minus 4ac all over 2a. Okay, so you find now the diameter. Okay, kindly compute. What is the answer po? Anyone? Sino po nakapag-solve? Hello? Ano ang sagot? Anyone po? You simply simplify this, okay? You divide this, tapos i-transpose natin to the other side. So, ang matitira naman po would be, on the right side of the equation, would be 10 over 0.785 for d squared minus this. Then you simply cross multiply to obtain the quadratic equation. Okay, so you identify which is A, which is B, which is C from the quadratic equation. And then using the quadratic formula, you'll obtain the
Ma'am, hindi po ba pwedeng mag-shift solve na lang po?
At least you should have here, okay, after this po, at least you should have here po the equation, okay? So I'll just see the equation and then you state there using quadratic formula what is the diameter, okay? So that is the time you use the shift solve, okay? No need for negative b plus minus square root of b squared minus 4ac all over 2a. But then you need to include here, okay? You need to include here the quadratic equation, okay? So what will be the final form? Okay, so that I can identify also which is being used as A, B, and C. Okay, so using what would be the diameter?
Yung 1.269445062 ka po.
1.269, yes, correct. 1.269, the next number,
445062 po.
so 1.2694 inches. Okay, so this is our answer. So your answer now is to be compared with your assumption. Okay, we go back to your assumption. So here, we assume 1.25 inches. So 1.25 inches, this is equivalent to 1 and 1/4 of an inch. Okay, 1 and 1/4. This is our assumption. And when you look at our answer, we have here 1.2694, and this is equivalent to 1 and 3/8. Okay, this is equivalent to 1 and 3/8. So you look at their standard sizes, okay? Different standard sizes, therefore, this is not yet your final answer. This is not yet correct, okay? The assumption and your answer should be of the same, okay? Standard size po, okay? So you need to recompute. Okay, so kung titignan natin, ay, ang lapit na po, 1.25, this is 1.27, ang lapit na. Pero, they are of different standard size, so you need to recompute. Okay, so for recompute, okay, you assume a different diameter. So, yung previous answer mo should be your next assumption. Assume diameter 1.27 of an inch. Okay, so just have it 1.27 instead of 2694. Kasi if you will be using table 88, okay, to obtain the value of KT, ito lang din naman po yung titignan natin. Okay, so using AF8,
ito pala, papalang natin magkuha equation na ito.
okay, using figure AF8, so ito mo po siya babalikan. Okay, you have your assumption, diameter 1.27, so again, find D over D, KT, and then solve for KF. Okay, so again, you find D over D. So this is 0.125 inches divided by 1.27. Okay, so what is now the value? And using this D over D, you solve for, or you estimate the value of KT using this figure AF8 on page 22. Okay, so you find value of KT. Once you have the value of KT, you solve for KF. Okay, KF is equal to Q times KT minus 1 plus 1. You would be using this new KT. Okay, same value po ng Q. You'll find now a new value of your KF. Okay, and from this KF, again, Okay, sorry.
And boss,
So from this KF,
pwede na natin siyang magamit. Because this was
you use now the Soderberg equation. Okay? So substitute again to Soderberg.
So, itong equation ay dimension of the circle.
Yan. Okay, so ito po ulit. Okay, so all components, okay, of the Soderberg the same except this KF. Okay, so you have ano KF, then you find another diameter. Okay, you look at this diameter. If it is the same as 1 and 3/8, then that would be your answer. Therefore, use diameter equal to 1 and 3/8 of an inch. I think this will be the same. 1 and 3/8 of an inch. Okay, so pakikuha nyo lang what is the computed value. It is almost the same as 1.27. Okay, so try to recompute. Nakuha po ba? Hello?
Yes po, ma'am.
Okay, so pakituloy nyo po ito kung paano nyo po siya gagawin. Okay, so ang babalikan nyo lang po, okay, would be on this part. Okay, you assume this diameter 1.27 this time, so you'll get a different d over d, kt, and kf. And then from there, you substitute again to the Soderberg. So this would be changed with the new value, and then you'll obtain a different answer. Okay, so try to see your answer there. I think that is 1.27. Okay, so the same commercially available size as 1 and 3/8. So that would be your final answer now. Okay, question. Any question? Hello?
Wala naman po.
Wala naman po. Okay. So you look at our sample problem. It focused only on one stress razor. Okay, so for the entire member, you only have here one stress razor, and that is the central hole. Okay, but then take a look at our illustration here. This is the machine member containing several stress razors. You have here a hole, you have here a groove, and you have here a fillet. Okay, so if the member comes with different, okay, or several stress razors, then you'll have several answers. So yung answer natin kanina is considering the whole only. Halimbawa, that is our answer. What is our answer? Considering the whole, what is our answer? Diameter is 1 and 3/8 of an inch. Okay, yung answer natin kanina. Okay, so you would have another answer. Okay, this time, you consider groove. Okay, so you consider the groove. So what would be your final diameter?
No,
Then,
you are.
if you have still a fillet,
I will be
so you consider the fillet. So you'll have a different answer. Okay, so from these three, okay, you need to choose the highest value. Okay, therefore use the biggest value of the diameter. That is when, okay, your machine member contains several stress razors. Okay, so yung answer po natin kanina ay di lang. Okay, kasi iisa lang naman siya. Pero kung madami po yun, edi dapat madami po tayong answer, tapos dun po tayo pipili. So yung isa po, kada isa po dito, ganun kahaba, katulad nung ginawa po natin kanina. Okay? Hello? Okay na?
Yes po,
Nakuha
ma'am.
mo ba? Okay? Okay. So you have here still, for the sample problem, you have their letter B using an indefinite life. Okay? So you try to solve using the indefinite life for letter B. Okay? So I'll stop my presentation now.
However,
Any questions? None? So try to open. Yes, Miss Alisa?
if we
Miss Alisa.
Ang pwede po ba mahingi po yung ano po, yung PDF po with the notations po para lang po ma-solve po namin yung sa problem po.
Okay, I'll save the PDF with notations and then send ko na lang po sa GC po natin. Okay, noted po.
Sige po, ma'am.
Any other? Any other? Wala na po? Okay, so let us have po attendance check. You open your camera. Alex or Rio Pasuyo.
Ako na po, ma'am. Game po. 1, 2, 3. Isa pa po. 1, 2, 3.
Okay, thank you. So our exam will be until this variable stress with stress concentration. Okay? Sige po. Thank you. Bye.
Thank you po.
Thank you po, ma'am.